Hey there, data-driven decision makers. Ready for a deep dive? Today we're looking at how we evaluate large language models.
And we've got a research paper here that really gets into how to make those evaluations statistically sound.
Yeah, because just looking at a high score
Right.
doesn't always tell the whole story, right?
Absolutely. It's like you wouldn't trust a medical diagnosis
Yeah,
based on one kind of noisy measurement.
right.
So this paper is arguing that we need that same kind of statistical certainty
Yeah.
when we're judging these powerful AI systems.
Okay, so the paper starts out by kind of highlighting this problem, the highest score wins mentality.
Yeah,
It's like everyone's just trying to win the AI popularity contest,
it is.
but forgetting to ask,
Right.
how reliable are these scores?
Exactly. Without error bars or confidence intervals,
Yeah.
it's really hard to tell if, is the difference between 80% and 85%
Right.
meaningful, or is it just random noise? It's like trying to measure a marathon runner's speed with a stopwatch that's a few seconds off.
Yeah.
You might get the wrong winner.
Totally. The paper uses this really cool example to drive home this point.
Mm-hmm.
They've got these two fictional models, Galleon and Dreadnought,
Right.
and they're basically in this head-to-head battle
Yeah.
on these popular benchmarks like math, human evil, MGSM.
Yeah. So you look at it,
Yeah.
and at first glance, it looks like Dreadnought is winning, right?
Right.
It's got 2 out of the 3.
Yeah.
But then when we actually apply the statistical methods that they
Yeah.
lay out in this paper, the picture gets way more complex.
Okay.
And sometimes that supposed winner,
Yeah.
not so clear anymore.
Okay, now I'm really intrigued. So the paper is proposing this whole framework for looking at language model evaluations.
Yeah.
Through this more statistical lens.
Right.
And the key idea here is to kind of imagine all the possible questions we could ask a model
Yeah.
as this huge superpopulation.
Right. Almost like a thought experiment, right?
Yeah.
We've got this massive set of questions out there.
Yeah.
And any evaluation we do is just taking a sample
Right.
from that huge pool.
Okay.
And that's a really important shift because it lets us then estimate how the model would perform on the whole population, not just the handful it happened to see
Yeah.
during the test.
So it's like if we're trying to figure out the average height of all adults,
Yeah.
we can't measure everyone.
Right.
So we measure a random group.
Right.
And we know our sample's not perfect.
Yeah.
But it gives us a starting point.
Exactly. And this is where the central limit theorem, right?
Yeah.
CLT.
Oh, yeah, the CLT.
This is a big one in statistics.
Yeah, I remember this.
And it basically tells us that if you take enough of these samples,
Yeah.
the distribution of those sample averages starts to look like a bell curve,
Right.
no matter what the original population's distribution was.
Okay, yeah, I remember learning about that in stats class.
Right.
But how does that apply to, judging AI? It feels like we've gone from measuring heights to,
Yeah.
I don't know, evaluating language.
Well, think about it like this.
Okay.
The CLT gives us a way to calculate the standard error of the mean,
Okay.
which is basically how much is our sample average likely to be off
Yeah.
from the true average for the whole population.
Gotcha. So it's like a way of quantifying uncertainty.
Exactly.
Like admitting that stopwatch might be a little off.
Right, exactly. And what the paper argues is that, using the CLT
Yeah.
is a much more, robust and kind of widely applicable approach
Okay.
than some other methods that are out there.
Right.
Like bootstrapping, for example.
Yeah.
It gives us a more solid statistical foundation.
Okay, so this is all making a lot of sense to me, but it also makes me think about all those comparisons we see.
Right.
Like all the different models out there.
Yeah.
It's like this constant arms race.
Yeah.
Everyone's saying their model's the best.
Yeah.
But are they really backing that up
Right.
with the evidence?
It's a great question. And that's something this paper digs into, right?
Yeah.
It's not enough to just have that high score.
Right.
We need to be confident that the differences we're seeing are real
Yeah.
and not just chance.
Or quirks of the evaluation.
Yeah.
Okay, well, you've definitely got me thinking about those state-of-the-art claims in a new light.
Yeah.
So what else does the paper kind of reveal about how to make these comparisons more rigorous?
Yeah.
Okay, so we got to be thinking statistically,
Yeah.
especially when we're comparing these models.
Yeah.
But how do we actually go about doing that?
Well, one of the key ideas in this paper is this concept of paired analysis.
Okay, paired analysis.
Yeah.
What is that?
So imagine you're trying to test 2 new fertilizers
Okay.
on tomato plants.
Okay, yeah.
You could plant them each in separate plots of land, right?
Right.
And just compare the yields.
Right.
That would be an unpaired analysis.
Okay. I feel like there's a better way.
Exactly. A more insightful approach would be to plant both fertilizers in the same plot,
Right. Okay.
carefully controlling for other variables like sunlight and water.
Okay.
That's paired analysis.
Ah, okay. So we're isolating the effects
Okay.
of the fertilizer by doing
Okay.
that.
By planting them together, we can kind of eliminate or at least reduce the impact
Right.
of all these other factors that might be confusing things.
Okay.
And it's the same principle when we're evaluating language models.
Yeah.
If we test them both on the same set of questions,
Right.
we can actually take advantage of the correlation between their scores.
Correlation. You mean like even if the models are different,
Exactly.
they might still kind of agree on which questions are hard.
Exactly. Even if they're different, there's still going to be some overlap in their abilities.
Right.
And some questions are just harder than others. So by considering that correlation, we can calculate a more precise standard error
Okay.
for the difference between their scores.
Gotcha.
And that can really make a difference in our ability to say, okay, is this model truly better?
So paired analysis gives us this more like powerful lens to compare.
Yeah.
But, the paper also talks about ways to reduce the uncertainty
Yeah.
within a single model's evaluation too, right?
Yeah. So we can use these kind of variance reduction techniques
Okay.
to kind of make our measurements as precise as possible.
Okay, like what are we talking about here?
So one interesting one is this idea of resampling.
Okay.
And this basically means we run the evaluation multiple times
Okay.
on the same set of questions.
So the model gets multiple chances to answer.
Exactly. We're giving it multiple shots
Oh,
at
yeah.
the same problem.
Okay.
And by averaging those scores,
Right.
we can kind of reduce the impact of any randomness.
Okay, so instead of just having one score for each question,
Yeah.
we've got multiple, and we're averaging them.
Exactly. It's like taking multiple measurements with that wonky stopwatch
Yes.
and then averaging them out to get a better idea
Okay.
of the true time.
Okay, so resampling sounds cool,
Yeah.
but isn't that a lot of work computationally?
Yeah, it can be, which is why the paper provides some guidance
Yeah.
on like how to choose the right number of these resamples
Right.
based on how much precision do you really need.
Okay, so sometimes a few's enough.
Yeah.
Sometimes you need more.
Exactly. It depends
Okay.
on the situation.
So it's that trade-off of
Yeah.
like computational resources
Yeah,
versus statistical certainty.
exactly. Another really interesting technique they talk about is analyzing not just the model's final answer,
Right.
but the probabilities it gives to each possible token.
Oh, okay, so we're kind of peeking under the hood,
Exactly.
seeing how confident it was.
Yeah, we're looking at its thought process a little bit.
Okay.
And this can be really helpful, especially in tasks that maybe don't have a lot of complex reasoning.
Yep.
We can kind of use those probabilities as a better measure
Right.
of what it actually knows.
Okay, that makes sense. What about adjusting the model's temperature?
Yeah.
I've heard that can be used to kind of like smooth things out.
Yeah, but the paper actually cautions against that
Okay.
as a primary means of reducing variance.
Okay.
Because while it might make the scores look more consistent,
Uh-huh.
you're actually changing how the model behaves.
So it's not a fair comparison anything.
Exactly. It's like we're artificially smoothing out its performance
Right.
instead of actually measuring its true abilities.
Okay, so it's like giving that runner
Yeah,
rocket-powered shoes.
exactly. Yeah, they might finish faster,
Yeah.
but it doesn't really tell us how good of a runner they are.
So we need to be careful about like manipulating the model,
Yeah,
even if we're trying to reduce variance.
exactly. We want to get a clear picture of like what it can actually do.
Okay, so we've talked about paired analysis.
Yeah.
We've talked about resampling, analyzing probabilities.
Yeah.
It feels like we're building this like statistical toolkit here
Yeah, we are.
to make sense of these models.
We are. And there's one more crucial concept we need to talk about,
Okay.
and that is power analysis,
Okay.
which is all about understanding, can our evaluation actually detect a real difference, given all this noise that we've been talking about?
Okay, let's dive into that.
Yeah.
All right, so power analysis.
Yeah.
What is it?
Power analysis is all about understanding the ability of our evaluation
Okay.
to detect a meaningful difference between models, if one exists.
So it's like checking how strong our magnifying glass is
Exactly.
before we go looking for those tiny details.
Right.
If it's too weak, we might miss the important stuff.
Yeah.
Okay, I'm with you.
Imagine you're trying to figure out if a new drug is effective. A poorly designed study, one with low power,
Yeah.
might completely miss the drug's benefits.
Okay, yeah. Makes sense. But we're talking about language models.
Right. But the same idea applies.
Oh.
Think about Galleon and Dreadnought, our fictional models.
Yeah.
Let's say we do an evaluation with low power,
Okay.
and we don't find a significant difference.
So we might just assume they're basically the same.
Right. But the problem is our evaluation just might not have been sensitive enough.
Oh, okay. So how do we make sure that our evaluations have enough power then?
Well, the paper gives us a formula
Okay.
to figure out how many questions we need to ask
Okay.
to achieve a certain level of power.
Okay.
It takes into account things like how big of a difference are we expecting to see,
Right.
and how much statistical certainty do we want?
Okay, so we need to really think about the number of questions we're using
Yes,
and how big of a difference we're actually looking for.
exactly.
This is really helpful. I mean, for anyone who's designing these evaluations,
Absolutely.
could save a lot of time and effort.
It's like trying to find a needle in a haystack.
Yeah.
If you don't have the right tools, you might be wasting your time.
Yeah, okay. This all makes sense. But it also makes me wonder about all the research papers out there,
Yeah.
all the product announcements I see about these new language models.
Right.
How can I, as someone who's trying to stay informed,
Yeah.
how can I be more critical knowing all of this?
Look beyond the headlines.
Okay.
When you see a claim about a new model's performance, ask yourself, how did they do this evaluation?
Okay, yeah.
Did they consider statistical significance?
Right.
Was the study adequately powered?
So don't just accept things at face value.
Exactly.
Look for the evidence.
And if it's not there, ask for it.
This has been a really insightful deep dive.
It has.
We've learned about the limits of traditional evaluations.
Yeah.
We've talked about some really powerful techniques for making them more rigorous.
Absolutely.
Paired analysis, variance reduction, power analysis.
Yeah. All these tools help us really understand how these models perform.
What's the one thing you want our listeners to remember?
Embrace a statistically informed perspective.
Okay.
It lets us ask better questions, draw more reliable conclusions.
And ultimately make better decisions
Exactly.
about how we build and use AI.
Well said.
This has definitely changed how I think about language model evaluations.
Good.
I'm already looking at those performance numbers a little differently.
Excellent. That's what we want.
Thanks for joining us on this journey. Remember, a statistically informed perspective is a powerful tool. Until next time, keep diving deep and keep asking those critical questions.